Let's talk about a powerful quality check that happens long before you ever get your hands on a new app or piece of software. It's called software inspection, and it's all about catching problems right where they start, way before a single line of code is ever run.
You know that feeling, right? An app crashes, a website freezes. It's just so frustrating. We usually only find these bugs after the software is out in the wild. But that's a really expensive and inefficient way to do things. So the big question is, why do we wait for it to break? What if we could find those flaws way earlier?
And that's exactly what this is all about. We're going to flip the script. Instead of just reacting to failures after they happen, we're going to proactively hunt for the defects before the software even runs. This is a total shift in mindset from damage control to pure prevention. So what is software inspection really? Well, think of it like a team of expert editors proofreading a book before it ever goes to the printer. They're not reading the final product. They're looking at the source manuscript, the designs, the code itself. And that's the magic right there. When you find an error at its origin, you know exactly where it is, which makes it so much easier to fix. This really gets to the heart of the difference between inspection and testing. You see, testing needs a running program so it can find failures, the symptoms of a problem. But inspection, it looks at the static blueprints, the code, the plans, to find the actual defects, the root cause of the problem. And the biggest advantage? You can start inspecting on day one. You don't have to wait for a finished product.
Okay, so this sounds great in theory, but how does it actually work in practice? Well, there are a bunch of different ways to do it, from super informal peer checks to really formal processes. But you know what? They all kind of follow the same basic blueprint. Let's take a look.
It really boils down to these three core stages. First, you plan and prepare the work. Then, you actually do the inspection and collect your findings. And finally, you correct the issues and follow up to make sure they're fixed. Plan, inspect, correct. It's a simple but incredibly powerful cycle.
Now, that first step, planning and preparation, is absolutely critical. You just can't skip it. This is where you set yourself up for success. The team has to get on the same page about what they're looking for. Is it security flaws, logic errors? You also figure out who needs to be there and what each person's job is. Without good planning, the inspection itself can turn into a total mess.
Next up is the main event, inspection and collection. This is where the team gets together and systematically goes through the document or code, and their focus is laser sharp. The goal is simple: find potential problems and write them down. That's it. Create a clear list of issues for the next phase.
And that brings us to the final stage, correction and follow-up. The person who owns the artifact, the coder or designer, takes that list of faults and gets to work fixing them. But, and this is a big but, you're not done yet. You have to follow up to make sure the fixes actually worked and didn't accidentally break something else. You got to close the loop.
This three-step blueprint is really powerful. But where did it come from? Well, for that, we have to jump in our time machine and go all the way back to 1976. A guy at IBM named Michael Fagan created a formal process that became the gold standard. It's basically the grandfather of all modern software inspections.
So, the Fagan method takes our simple three-step process and adds a bit more structure, expanding it into 6 steps. You can see how planning is broken out into its own planning phase, an overview meeting, and individual preparation. And correction is split into rework and follow-up. This extra detail just adds a layer of discipline that makes the whole thing even more effective.
This whole process was designed for a pretty small, focused team. Through all his research, Fagan found that the sweet spot, the magic number, was right around 4 people. Any more than that, and things can get bogged down. This keeps the meeting moving and makes sure everyone gets a chance to contribute. So who are these 4 people? Well, the key here is diversity. You don't just want 4 developers in a room. The ideal team brings together people from different roles. A designer is going to see things a coder might miss. A tester thinks about how things can break in a totally different way. That mix of perspectives, well, that's the secret sauce. Now, this is probably the single most important rule of a Fagan inspection. I want you to really let this sink in. The goal of the meeting is to find problems, not to solve them. It's so tempting to start brainstorming fixes on the spot, but that's a trap. It just wastes time and kills the momentum. The job is to find the flaw, record it, and move on.
This means that the success of the actual inspection meeting, which usually lasts about 2 hours, depends almost entirely on the homework everyone does beforehand. Each person has to review the material on their own and come prepared with a list of potential issues. You can't just show up and wing it.
The meeting is for combining everyone's findings, not for seeing the material for the first time.
So, after all these decades, what have we learned from the Fagan method? Why is this idea from the 70s still so important today? Let's talk about its incredible legacy.
Well, years and years of practice have really hammered home Fagan's original lessons. We've learned that individual prep work is absolutely non-negotiable. We've also figured out that the process is flexible. You can tweak the team size and roles. But maybe the most valuable thing is that the data you get from inspections creates this amazing feedback loop that helps improve the entire development process.
And that is the real legacy here. You might not hear the name Fagan Inspection tossed around in your daily meetings, but I promise you, its DNA is everywhere. Modern code reviews, peer programming, architectural walkthroughs, they are all direct descendants of this foundational idea, just adapted for our fast-paced, agile world.
So this leaves us with a pretty fascinating question, doesn't it? In a world of artificial intelligence and constant automated testing, how can a methodical, human-focused idea from the 1970s still be so incredibly relevant? I think the answer is that some things just don't change. Getting a fresh pair of expert eyes on a problem and having a structured conversation about it, that's still one of the most powerful tools we have for building better software from the very beginning.